Today we talk about distributed computing. The talk is meant to be an hour normally, so I have an excuse because it's just 30 minutes. So first of all, I would like to know how many people here are familiar with Hazelcast? Okay, so it's almost half of the audience. Is it okay if I skip some kind of the basic stuff, or do you want to see more like basic coding, how to get Hazelcast started? So who's more for getting started? Okay, and who's more for the Mapreduce kind of things? Well, it's 50-50. That's a good thing. I guess we're going with the Mapreduce, and if something is unclear, just keep me asking, and I'll try to explain it. So, just as a quick introduction. I guess you know that from a lot of other companies, blah, blah, blah. It says mostly, don't do business decisions on whatever I talk about. This is me. Just call me Chris because the name is German. In Belgium, it might be okay for you, but in a lot of countries in the world, they can't pronounce it. I'm doing 8 years of Java stuff, 8+ years. I'm a Apache committer. I was working at the gaming industry at Ubisoft, travel management, which means HRS. And normally that would be the roadmap for this talk today. We're skipping the Hazelcast and distributed computing part and just straight switch to Executor Service, entry processor, and Mapreduce. And I'm also skipping the slides, so we just go over to the distribution itself. So let's see. I have prepared all the examples, so if something happens, I'm fully set. And we start by Executor Service. I guess most of you guys know the Executor Service in Java. So what we do is we have a fully distributed implementation of the Executor Service. That means it looks like Java, and you can just run your runnable and your callable in a distributed environment without thinking about it. So I have some template code. It starts up a 3-node cluster. Let's make it 2 nodes to not take too long. So I'm starting 2 nodes. I will add some code between the try and finally, and eventually I'll shut it down. And I'm just make sure in the configuration that I only connect to my local notebook, because if somebody would start up another Hazelcast cluster, it might be a problem. So let's see. We want to do something like, we want to show that our runnable we just create is really distributed. So I have some helper classes, since the Java 8 runnable is not yet serializable, and I just want to have lambdas because they're cool at the moment. So I have this interface which has just one method, and I have an adapter which wraps that lambda later on in a normal runnable. So I can use that one, and I say, well, I have a runnable. The wrap method is missing. So I'll take this one. And I say, please wrap my method, and I have a Hazelcast instance. And I want to say, system out, print line, hello world. Oh, hello DevOps for sure. And then let's take the Hazel. Get cluster on get local member. Let's make it that way. Okay, so I create a lambda which gets the current Hazelcast version, the current Hazelcast instance of the cluster I'm running on, or of the cluster node, and I'll just say hello from hello DevOps from, and hopefully, eventually, it will show that we have 2 cluster nodes. That is what is expected when you have 2 cluster nodes. So what we say is we get the executor service. And instead of saying executors.new scheduled executor service or something, you say, well, Hazelcast, please give me an executor service with a name. Whatever it is, as long as you request the same name on all cluster nodes, you get the same instance. Well, and then you're almost set. You just say, I executor service because I want to move it to all cluster nodes. And you say submit to all members. Execute on all members, for sure it's a runnable. And then you execute it. And it's compiling. Connecting. And there we go. So see, I have two cluster nodes. One is running on port 5701 and one is running on 5702. So I just created one runnable and I set the executor service, please execute it. And because I said execute on all members, it just serialized the runnable and sent it over to all the cluster nodes and execute it locally. If I would just say execute, we would get an execution on just one node. So the cluster just takes one node and executes the runnable over there. It's about, and this time it's the second node. If I run it again, it might be the first one. If I have more cluster nodes, I can just have some kind of load balancing right from cluster side. Okay, so far the executor service. Some questions about it. Okay, so there is one question? No. Okay, so the executor service is meant to be for easy distribution of operations. So you just start up the cluster, you have your runnables and callables, you send them over, and they are executed. We have distributed locks, so you might do some kind of locking around it. But if you want to work on data that are stored into Hazelcast, this is not the best way to go. The thing is that if you store data into Hazelcast and you have multiple cluster nodes firing up operations, they end up in thread pools. That means you would have to do some synchronization, locking, and kind of things. Normally in a cluster environment, you don't want to do that because it works against scalability. So what you can do is you can have an entry processor. An entry processor is like a user-defined operation that runs directly on the operation partitions. So you get some kind of an implicit lock because everything is serialized for a single key. So there's only one operation per key at the same time. I'm not doing this example because I did it a few times and I always fail because it's a bit more complicated. So what this thing does, or what that code example does, I get a map and I start a counter called foo with the value 1000. And then I create an entry processor, which does an amazing increment. But what we see is that the incrementation is not a single-shot operation. So I'm reading a value, I'm changing the value, and I'm setting it, and I'm returning it. That means in Java terms, this is not meant to be atomic. But the entry processor makes it atomic because we have the implicit lock around it. So I want to increment the value 1,000 times, and I'm doing with 1,000 threads. So in an incrementing only counter, I expect never to show up as value 2 times. Well, we know that threads are running in kind of parallel at least. So the underlying Hazelcast system makes sure it's not happening. We do that by, we have the map counters and we have execute on key. Execute on key gets the key it's running on, and we put in the processor we want to operate on. That means we 1,000 times, we now put the operation for the incrementation on the queue, and we just work on that one by one through the operation. So, any question on that? No. Okay. So if I run that one, we hopefully see that we don't get the same value 2 times. I'll make it a bit bigger. And we see that the operations are serialized and you never get the same value 2 times. The good thing about it is the same the same amount of work for the Hazelcast cluster as you would get the value. So you just send over the operation, and we get the value and we directly store it again. So it's not like you have to get it over the network to your node you're working on, and you change it and you send it back. It's just like a one-shot operation right in place. Any question on that one? Okay. And then let's go to the part that most of the people might be interested in, the Mapreduce part. So how did use Mapreduce upfront or before? Some people that already used Hadoop or InfiniSpan Mapreduce or something? 1? Okay, 2, 3, well, okay. But you know how Mapreduce works, or should I quickly go through the slides? Oh, maybe let's do the slides on that. Okay. The topic is Mapreduce, the black magic from Planet Google. What is Mapreduce used for? It's mostly used for log analysis. I guess it's one of the most common things. You can do data querying. Data querying mostly means like parallel querying data on the different nodes and aggregating them together. You can, for sure, if you query the data, you can aggregate and sum them. You can do distributed sorting, and well, extract, transform, and load means something like you read data in, you transform them, and you might write data back to a database in a transformed way. Well, there are a couple of more use cases, but those are the most common ones. So the simple steps are you read data into the memory in Hadoop. It's from HDFS into memory. You map and transform them. That means you either just select them by different criteria or something. You might even change it, like, okay, I get a sentence and I want to have it in single words. And eventually you reduce the result, whatever it might be. So what we look at in a couple of slides is the typical Mapreduce hello world. It's the word count. That means you get a sentence or a big bunch of texts, and you want to find out the frequency of different words. So what we do is, in full steps, we read in the files into memory, the different documents, which map them, which means we split up the sentence and we move on the different words or the single words. Combining in this case means, we will show that later, combining means before sending over the different words to the other nodes for reducing, we look like, oh, I've seen a word 4 times, so I don't have to send it over 4 times. I just say, well, I've seen that word 4 times. Grouping and shuffling is like partitioning. It means you find out which node is performing the reducing step for for a given word. And reducing means you take all the word counts and you just aggregate them together for the result of the given word. Collating is like a final operation which is not defined by Mapreduce itself. So in a distributed environment, you might have multiple values, and to speed up the operation, you split the reducing steps into multiple operations. And collating can be something like, okay, I want to have the top 10, so I'll try to split it up, and eventually I want to have the final top 10. That means I have let's say, 4 segments of each 10 elements, and then I'm in the collating state. Collating phase. I'm getting the 40 elements, and I'm selecting the real top 10. This is, I guess, created by Infinispan. I found it very interesting and practical, so I started to implement it as well. What is a Mapreduce like? As I said, you have different input sentences in this way, just sentences. You split up the single words, and you say, well, I've seen Saturn 1 time, and I've seen is 1 time, and planet 1 time, whatever. And in the grouping phase, you collect those together, like is coming from all 3 sentences, or planet is coming from all 3 sentences. And reducing is just like aggregating or summing up the different elements. And then you get your final result, which is like, okay, this is the frequency of the different words. If you would have a combining phase, it would be here. And if you would have a sentence like, Pluto was a planet, but is not a planet anymore, it would say, okay, I've seen planet 2 times, and instead of sending over planet 1, it would say planet 2. We will do it in a bit, so we see the real difference. I guess we can skip those. If someone likes mathematics, well, that might be interesting. So let's go to the source code. That might be the most interesting one. Again, let's remove that one. So I have, that's not it. I have 3 different lorem ipsum texts, just generated on the internet, as you would normally do. I'm reading them into an input stream, getting the different values, blah, 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 putting it together again and storing it inside of a map. So what I do is the file name is the key of the file, and it's more like a document storage in this case. So let's see, we create a new package. And we start by implementing a word count mapper. I'm pretty sure I'm getting it wrong. We have input string. So file name is a string and the document is a string. And what we put out is we have a string, which is the word, and we have an integer, which is the amount of, oh, come on. Which is the amount of the word. In our case, it's always like private static final integer 1, since we always emit 1 as value. So we get string tokenizer. Oh, come on. Sorry. And we split up the word, and we say, okay, well, we have more words, has more tokens. We want to emit the token itself. What is it? Next token, there you go. And 1. So in this case, it would work, but for some reason, the tokenizer is kind of weird. So we have, I guess it's word count, clean word. This one gets the next token. It cleans out all punctuation for some reason that is part of the splitted word. So let's do it that way. So now we have a mapper. The mapper gets the document, it splits it up into its different words, and it says, well, I've seen that word 1 time, I've seen that word 1 time, and so on. So any questions so far? No. Okay. So now we're going over to the reducer. A reducer is meant to run one reducer per key. In this case, one reducer per word, which means we have multiple reducers on each node possibly. So we don't create the reducer directly as you would do it in Hadoop, but you have a factory, and the factory is used to create a reducer in runtime. So we have word count, reducer factory. Okay, file already exists. Oh, wrong package. Reducer factory. And we get string integer, which in this case means the word and the count, and we return a count. Okay, and we just create a private static class, which is the actual reducer itself, word count. Extends integer. So we reduce from integer to integer. I think that makes sense. We have some value here, which is initialized by 0. And the reduce method is called for every single value that is reduced eventually. So we just say value plus equals value, this value. Sorry, I'm a bit ill, so I hope you don't mind. And eventually we say, okay, if the reducing step is finalized, so there are no more new values, please give me the reduced value. Okay. What happened here? It created an implementation. That's whatever. I want to have. Okay. And for sure, I have to create it. So when I create a new reducer, I could store the key that it is created for, but I don't have to. Change extends to what? Whatever. Okay, so yeah, whatever. So to get a MemReduce job, I get a job tracker. A tracker is meant to be a single shared resource between different MemReduce jobs. So you can configure the underlying thread pool of the different nodes. You can configure the streaming behavior. So we do kind of batching or chunking underneath. So it seems like you're streaming the results. So you can work on amazingly huge data sets. And those kinds of things are configured using a job tracker. So you ask Hazelcast for the job tracker, and we go again for default. You say you have the key value source from string. The key value source is kind of an adapter between any kind of input source, and it creates key value pairs. So for map, it's easy because it's just taking a key value pair and returning it. But we also have multi-map, we have the lists and sets, and you might also want to implement your own one. It's more like an extended iterator. So for normal stuff, we have some helper methods. For sure, we need the map. Map name. And then you say documents. And then we start with the actual job. We start by string, because still the file name and the document name. And you say, okay, I have my tracker and I want a new job, which is fed by this key value source. And we have the future, and we know in the future there is a map that maps between the words and the frequency. So we have the future here, and we say, okay, job, I want to have a mapper, which is now my new word count mapper. And I also want to configure the reducer, which is new word count reducer factory, but not that one. Oh, well, it doesn't matter. We can go for that one. Just need to remember to change the right one. Okay. Let's make it correct. We want to have that one. It's not, oh, that's the difference. Okay. So I can run this now and it will work. So whatever. File name. Oh, okay, got the point. Let's do it differently. Reducer. Okay, now it should work. Come on. Oh, I still have 3 nodes. So we see, stop it. Here's the frequency of the different words. Normally, what I would do is I'll show first that only ones are arriving at the reducer. So if I would put in here a system out print line and would print the value, I would see that it just says 1111. Because of time reasons, you just have to believe me. I'm absolutely right on that. So we're going for creating a combiner factory for the same reason. It might be that there are more combiners than just one. Combiner factory, and again, string integer. Integer. Word count combiner. It looks pretty much the same way as the reducer because it almost does the same things, but the difference is it does not say finalize combine, but finalize chunk. As I said, we're using chunking internally, so it is meant to be called more than once. Before I forget about it, let's make it that way. And again, we have private. This volatile is in the old API required because the combiners can jump between different threads, but it's not in the upcoming version, so we changed it differently. So again, we have value. So you don't need to remember that one. Just believe me, it's not required anymore. And we say value, and to make it nice, we use the reset method, and the reset method is meant to set value to 0 again. You can do it in the finalized chunk anyways, it doesn't really matter. So how to set the combiner to reduce your your traffic, oh man, it's pretty easy. Just say, I have a new combiner and I want to use that one. And you're good to go. And if you run it again, you see it's not working again for sure. For some reason it keeps changing. Cannot find symbol. Yes, whatever. I love if anything works. Anybody an idea why it won't work? Let's try the other one. Let's remove that one to make sure it's not the one he's using. Whatever happens here. And I'm running out of time, so let's give it a last try. I don't know. Sorry? Oh, rebuild project. Oh, yeah. That might be it. For sure. Have you tried to turn it off and on again? So the result will be the same, but as I said, so the words are now pre-combined. And instead of sending over the same word a couple of times, you're just sending it once or maybe twice if it happens on multiple chunks. So if I stop that again, the result is the same, but the underlying traffic is different. As I said, sorry, time is over. Normally I show show the difference. So, any question? 30 minutes is quite quick over. If you have any more questions, hook me up. We have a booth downstairs, and if you have any question, especially people that are not used to Hazelcast yet, just come by and ask your question. All right, thanks.